We got it. Okay, our topic this evening, ladies and gentlemen, is the moon. Now, this is an updated version of a program I prepared for the Beechwood County Library System. So we'll get right into it. We've got a few views of the moon here. There's all kinds of pictures of the moon, and I don't know how the plane got that close to the moon. It's 238,000 miles away, but it's a nice shot. A few quick facts. The moon's age, 4.5 billion years, the size, the distance from the Earth, which varies because the moon has an oval orbit, it isn't circular. And the moon is gravitationally locked. I don't know what, if somebody's not muted.
Yeah. Hey, Bill, if you will pause speaking for just one moment, let me mute everyone. Stand by,
Okay.
please. Okay, everyone's being muted, and now I have to unmute Bill. Come on, Bill. There we go. Give it a, hold on, stand by. Unmute yourself there, Bill. Give it a try.
Okay.
Yeah, go ahead.
Am I back?
Yes.
Okay. The moon, of course, is no air, no water, although there is ice on the moon. No sound, very hot and cold. Okay, now it is not moving.
You're going to have to click on the screen.
Okay. Okay. The moon is actually the coldest known place in our solar system. It's colder than Pluto. They've discovered that the temperature in some of the craters is 400 degrees below zero. And in outer space, the temperature is 455 degrees below zero. So the moon is, and at least in those deep craters where the sun doesn't shine, the moon is pretty darn cold. Now, where did the moon come from? Some people may wonder that, and of course, members know right away. It started with a huge gas cloud of hydrogen and dust, and it isn't the kind of dust that you see in your house. It's minerals and elements, and it all came together when these clouds collapsed, and it started circling, and the sun at some point got hot enough to start nuclear fusion. And I think it might be 2 million degrees Fahrenheit when it kicks off. During the process of formation, there was all kinds of crashing and banging. Planets were formed, destroyed, so on and so forth. And during this process, scientists think that a Mars-sized object that they named Theia crashed into the proto-Earth and merged with it. Now, Theia is in mythology is the mother of the moon, the mother of Selene in Greek mythology, was the mother of the moon. These two objects merged pretty much, and what happened is that they were molten, and a piece of the molten mass flew off and became the moon. And it cooled over millions and billions of years and turned into what we have now. The impact with Theia tilted the Earth and knocked it off to about 23.4 degrees, and its axial tilt. And this tilt is what's given us our seasons, 23.4 degrees. And you can see here, the seasons change. The axial tilt remains the same all the time, but as the Earth goes around the sun, different parts, the northern hemisphere, the southern hemisphere, are exposed to the sunlight, which creates summer in those hemispheres, winter in the other one. But the axial tilt and the collision with the Mars-sized object is what has given us our seasons. Now the moon is, you can see what you got an inner core and an outer core. Scientists think that there's still a molten core, a small one, inside the moon, but it's not for sure, but it possibly is still there. And of course, the moon is very small compared to the Earth, and that's why it cooled off so fast and solidified. Now, the moon is made of, here's a composition of it, if you want to take a moment to look at it. Several new minerals were discovered on the moon by the astronauts, the Apollo astronauts, malcolite, tranquilite, and peroxferrite. Hard to pronounce, but those were new minerals that were discovered on the surface of the moon. And the rest of it is, similar minerals and rocks to Earth: olivine, pyroxene, feldspar, so on and so forth. And here is a false color image of the moon. The bright pink is the highlands, the blue, orange, volcanic lava, dark blue, titanium over here, light blue, I have to read it here, recent impacts, and the green and orange is Mare basalt. This is the western side of the moon, a waning moon that you would see. Now, 3 billion years ago, there was what they call the Great Bombardment. Something disturbed the asteroids out in the between Mars and Jupiter, or even farther out, and caused them to come flying into the inner solar system and slamming into the moon, the Earth, Mars, Venus, and Jupiter. The Earth was hit just as much as the moon, but because of weathering, the big impact craters have just pretty much disappeared on the Earth. But on the moon, because there's no weather, they've stayed. This is the backside of the moon here, by the way. Now, on the modern moon, on the side we're familiar with, which is more interesting and looks better, you've got these huge craters, the lunar maria, which are areas of lava. This is Oceanus Procellarum, Mare Imbrium, Sea of Rains, the Sea of Tranquility, the Sea of Fertility, the Sea of Crises over here, Mare Crisium. And that's that. After this happened, it's been this way for billions, a long time. It's 4-point-some billion years old. So once the moon solidified, it stayed that way. One interesting feature is that the moon has no magnetic poles, so a compass would be no good up there. And it also has a very short horizon. I think it might be a mile. So let's say you're roving around on the moon, you could go over the hill and not be able to find your way back. So astronauts, or the NASA, came up with a device, I think, which is up here, where the astronauts were able to use the position of the sun to determine their location on the moon, whether they were north, south, east, or west. But compass will not work on the moon. Now, one of the important things the moon does is it serves as a stabilizer to help the Earth maintain its axial tilt. And I've read that if the moon were not here, the tilt of the Earth could change over time, over millions of years. It could go one way, go another way, it could turn sideways. So this has stabilized us and maintained and helped maintain the seasons that we have: summer, fall, winter, spring. And if the moon disappeared, we'd be in trouble over a long period of time. The moon's gravity, of course, also causes the tides. And this, scientists think this was the key to the start of life in our oceans, the sloshing of the water back and forth, rising and falling of the tides. If there were no moon, the ocean would have no tides. And this is how the phases of the moon. They made it out of cheese. This was from this illustration. But why it goes from waxing crescent moon, the first quarter, give us full moon. And then this is when the moon is rising over in here. And then over here is when it's setting. And then it goes to new moon when the moon is right between the earth and the sun. And the sun is shining on that side of it. And we see darkness on the side that we're facing. So this is how it works. It's kind of, it's hard to explain a little bit because it's complicated. The moon's orbit is tilted, 5-degree tilt. And that's why we don't have eclipses every month. And the moon has an oval orbit. When it's far away from us, it's the apogee moon, and it's about 250,000 miles from us. And the perigee moon is when it gets closer. It's at about 221,000 miles. So there's roughly a 30,000 mile difference as it goes in its orbit around the Earth. The terminator marks the point between night and day on the moon. Now, this is a waxing moon, and the sun is rising. On the side where the sun is, it's hot, real hot, 260 degrees Fahrenheit. And the shade, it's 280 degrees below 0 Fahrenheit. And the sun rises and sets, and the terminator moves at about 12 miles per hour. So if you wanted to stay out of the heat, you'd have to walk pretty fast so that the sun didn't overtake you. Now we'll talk a little bit about craters. There's 3 main types: a simple crater, complex, and floor fractured. This is a simple crater, Isidorus. It's 26 miles across. And you can see here where boulders have rolled from the rim down the sides and created tracks in the dirt, in the regolith. A simple crater is bowl-shaped, and it depends on the size of the impactor that hits, whether the crater is simple or complex. Here's a simple crater on Earth. This is a meteor crater in Arizona, or what's called the Barringer crater. It's about a mile across. So the one we just looked at, Isidorus, is 26 miles across. Meteor crater is a mile. And you can see the size of it here. This is the parking lot for the visitor center. Here's the building for the visitor center and the road coming in. They think it was an iron meteorite that hit in this place. They've found fragments of it, but there's nothing buried. There's nothing buried in there underneath. They've investigated it. And the reason this hasn't disappeared is because the climate in Arizona is so dry. Now, when it hit, this is what happened. Fireball out to 10 kilometers, out to 24 kilometers, large animals or people, if there were any people back then, and I believe this happened 50,000 some years ago, they would be killed by the impact, the concussion. And then out to 40 kilometers, there'd be hurricane force winds. You can see the town of Winslow and whatever. So anything that was close to this would have been in a lot of trouble. Now, I read a story about the park ranger for Meteor Crater was describing what happened, so on and so forth. And one of the visitors said, "Wow, it's a good thing that the meteor missed the interstate highway," and because he thought it would have wiped out the interstate highway, but of course it happened way before they built an interstate highway. And now this is a complex crater, Copernicus, and this is one of the huge craters on the moon. It's 57 miles across, and it has central peaks in it. Now these central peaks are about 4,000 feet high. And the other characteristic of complex craters is terracing. The energy from the impact goes out sideways into the walls and breaks the rocks up, cracks them. Then gravity pulls them down in landslides that form these terraces here. We see 1, 2, 3, 4 terraces. And these are huge, huge landslides. If you figure 57 miles. And I think the central peaks I may have mentioned are they're 4,000 feet high. And we'll explain later where they come from. Now I've seen these through my telescope. You can see them, and it's this is where Copernicus is located. Now here's what creates the central peaks. If you've ever thrown a rock into a pond, it goes kerplunk, and then the water shoots up like this. And the same thing happened on the moon with the complex craters. The force of the impact compressed the surface of the moon, and then it sprung back up and instantly created the central peaks, created the big hole, and the mountains that are around them. And here's one of the biggest craters on the moon. It's Petavius. It's 109 miles across. And when I was a member of the Lunar Picture of the Day Club or group, I mentioned that, wow, how neat it would be to stand on the rim and be able to see across this thing. And Charles Wood, the lunar expert, pointed out to me that because of the shortened horizon, you couldn't see even as far out as the central peaks. You have to be up elevated way above the surface in order to see the whole thing. So this is what's called a floor fractured crater. Now this crack here is about 50 some miles long, and it's 1,000 feet deep. They've done studies with the Lunar Reconnaissance Orbiter. So you have a crack that's 1,000 feet deep. These are the central peaks. They're about 5,000 feet high. And this crater is unusual because it has a double rim. There's a rim here, another rim there, and you have the terracing. Now, it's called floor fractured because lava at some point came up underneath the floor of the crater and raised it up, and it caused these cracks. And there's a few other craters like that, but this is a floor fractured crater, the third main type of craters. And Petavius is located over here, and it's when there's a crescent moon and a waxing moon, that's about the best time to see it, when the light hits it from the right angle. Here's another floor fractured crater. This is Gassendi, and which is known as the Pearl Ring crater. Here's the pearl, here's the ring. Here's another view of it. Here's the pearl, here's the ring, and you can see this crater was really floor fractured. The central peaks are here, and the lava came up from the bottom and broke the surface of the crater. Now we have the Maria, the lunar seas. Back when the astronomers were first able to look at the moon when the telescope was invented, they looked and they thought these were oceans. And so they called them seas. And we have the Sea of Rains, the Sea of Tranquility, the Sea of Fertility, the Sea of Nectar, the Sea of Crises over here, and Oceanus Procellarum over here. And this down here is Tycho, one of the another outstanding crater on the moon. And with this image, this is a reverse image. You can see the extent that the crater rays shot out when Tycho was created. This area here is known as the zone of avoidance. Scientists have done ballistic tests with big guns, and they fired in and they discovered that this area of clear area of avoidance is created on Earth when you hit something with an impact from an artillery gun. The craters, of course, the rays went almost halfway across the moon. So this must have been quite an impact. Other craters on the moon, the crater rays have been erased. And what happens is that weathering takes place, space weathering from the sun and from micrometeorites hitting, so that the crater rays become gray, like the background, and so they don't stand out. Now here is Mare Crisium, one of my favorite places because it's easy to look at. It's 345 miles across, and it was an impact or impactor made a basin, and then it filled in with lava, and they estimate the lava is about 3 miles thick, about 15,000 feet thick, filled in from the bottom, and created over here what are called ghost craters, where they've been filled in. Here's one over here, filled in with lava, and you can just barely see the tops of the rims of the crater. They call them ghost craters. Over in this area, there's been reports of lights and some kind of stuff visible that scientists think are outgassing. The gas is being released from inside the moon. And over here where the arrow is what's called O'Neill's Bridge. And an astronomer back in the late 1800s, I can't remember his first name, his last name was O'Neill. He was an amateur astronomer and a columnist for the Chicago Tribune. Well, he was looking through his telescope one night and said, gee, there's a bridge there. Now, he didn't think it was a man-made bridge, but he thought it was a natural bridge, like you see down in West Virginia and in other places out west. So he contacted a friend over in Britain, an astronomer, and said, hey, I found a bridge. And the guy looked at it through the scope and announced it to the British Astronomical Society. And when news of this was announced, all telescopes around the Earth, they all started looking at it. And that's when they discovered that it was an optical illusion. What is happening here is that there's a gap between this promontory and that one. There's a gap there. And what O'Neill and the British astronomer were seeing was the sunlight on this structure right back here, which is a remnant of a crater. So the light was shining on this, and it looked like it was a bridge, but it wasn't. So then they were laughed at all around the world, and they were mean back then. And the guys, the British astronomer, his credibility was damaged, and it had a bad effect on his career. But I've seen O'Neill's Bridge with my own telescope. You have to hit it at the right time when as the sun moves along, and the sun's rays hit it from this side. Here's Mare Imbrium, the Sea of Rains. This is Plato. Here's Copernicus down here. You can see the crater rays from Copernicus. And this is another crater. These are the Apennine Mountains. And what happened, these are the Jura Mountains. I don't know if Maria Jura is with us, but I don't know if she was named after them or they were named after her. But these are 9,000 feet high, these mountains. And here's Plato, another one of my favorite craters. It's 67 miles across. And what happened here is that a huge hole was created. And it was most likely a complex crater because you can see remnants of the terracing over here. Lava came up from underneath and filled it like water in a pot. Filled the crater almost up to the top. Now, over here is a 9,000 foot peak named Plato Zeta. And one morning I was out 4 o'clock in the morning looking to see the straight wall and decided to go up north to Plato. And I was looking at this and, excuse me, just as I turned my scope on it, the setting sun hit the top of this 9,000 foot peak, and a spiky shadow shot out right across the floor of the crater, almost halfway across it. I saw it happen with my own eyes. And I posted a message on the lunar website, LPOD, and some guy said he's been trying for years to see that effect, and I happened to see it just by accident. You know, I wasn't planning on it. I never knew about it before. I just turned my scope on it, and zap, out went the shadow. This is called the Black Lake. Here's Sinus Iridum, the Bay of Rainbows. Now these are the Jura Mountains. They're about 9,000 feet high. And over here is Cape Laplace. And down here is Cape Heraclides. Now this one is where the woman and the moon can be found. If you hit it just at the right moment, when the light is just right, the rocks look like this profile view of a woman with long hair behind her. I've never seen that, but it's I'm told that it's there. Now this area, of course, this is all lava. Now the lava on the moon is not like lava on the Earth. Moon lava, Apollo astronauts brought some back, and the scientists melted it, and the moon lava, when it's molten, is runny and thin, like maple syrup. Whereas on Earth, the lava is thin, or is thick and viscous, sticky. So the lava on the moon is different from the lava on the Earth. Now here's an impact basin, Mare Orientale, 600 miles across, and it's 21,000 feet deep. Now this basin has some lava in the bottom of it, and what's known, it's called impact melt. When the meteor hits, there's a lot of heat generated, it melts the rocks, and then it comes back down and is solidified. This has got 3 mountain ranges: the Cordillera on the outside, the outer Rook, and the inner Rook mountains. But they were all created instantly by the force of the impact, just bam, and then the next instant the mountains were there. Nothing like plate tectonics ever occurred on the moon. So any mountains that you see were created by impacts. Now here's the biggest impact, and this is considered one of the largest impacts in the solar system. This is on the back side of the moon, or the far side. It's the South Pole Aitken Basin. It's 1,600 miles in diameter and 5 miles deep. And some scientists think that this impact almost destroyed the moon, almost broke it apart. And if that had happened, we'd be in a lot of trouble. So fortunately, the moon held together in spite of this tremendous impact that hit there. Here are the Apollo landing sites. Apollo 11, where Neil Armstrong landed. And these are where automated robot landings took place. From 1969 to 1972, the Apollo astronauts went up to the moon. And this is where Neil Armstrong and Buzz Collins and Aldrin landed, right about here. And they named little craters after them. They went down into this Hypatia rim, and it looks like a ditch that was dug out. And it was caused by land settling, or the surface of the moon settling. These are 2 of my favorite craters, the Messier crater. And this is like, there's 2 of them. And they were created by a giant ricochet. A meteor came, if the moon had trees, the meteor would have been skimming the surface at treetop level at about 6,000 miles per hour. And it hit the surface and it skipped, like when you skip a stone on water, if you've ever done that. So the meteor hit here, bounced up above the surface, and then came back down about, I think it's about 15 miles distance, and created the second crater. and they're about 5,000 feet deep and about 5 miles long. Ricochet craters. Here's another crater, Archimedes. These are the Apennine Mountains, which are on the edge of Mare Imbrium. And the mountains were created instantly by the impact, just bang, there they were. And this crater, Archimedes, was filled in by lava, which you can see surrounding this area right in here. Now here's Aristarchus, the lunar lighthouse, it's called. It's very bright, and you can almost see it with your naked eye, you know, if you're out looking. And this is Aristarchus. This is Prinz. And the reason it's so bright is that it's a relatively recent crater, and it brought up materials from beneath the surface that are light colored, and there hasn't been enough time yet for solar weathering to darken things. Now here is the Cobra Head. Now this is a valley about 90 miles long, and lava came out of this thing, cut this channel out to Oceanus Procellarum, which is out over here. You can see it there. The cliffs are about 1,000 feet high. And when I first saw this, I was thinking, wow, there's got to be a big cave there. Well, I saw pictures of it taken from different angles. It's all sealed up, you know, it's no cave, just a depression. But this Prinz over here and Aristarchus and the Cobra Head are on a plateau. It's a raised, elevated area that had a lot of volcanism going on underneath it. Neil Armstrong reported seeing lights when they went over this, when they flew over this crater. And again, they think it was gases being released from the surface underneath the moon. And here's an interesting crater called Wargentin. It's 52 miles across. Now, if you remember Plato earlier, the Black Lake, this one, the lava came up from underneath and filled the pot right to the top, and it flowed over the side. So this is totally filled with lava. It's on the southwestern limb of the moon, and you have to catch it at the right angle with the light to see it. And here is Reiner Gamma, a magnetic mystery. Looks like a crater there, but the surface is flat. There's no crater. And there's something buried under the surface that's highly magnetized. And it's deflecting the solar rays and preventing the sun's space weathering from taking place. So it's wherever the magnetic effect is, the surface of the moon is lighter in color. And here's a closer view of it. I like to think there's a giant alien spaceship buried under the ground there, and it's still operating with its power. That's science fiction stuff. But this is one of the areas where NASA would like to go and find out what's going on there, because the Earth has no magnetosphere, and there are areas of remnant magnetism that are frozen in the rocks. This might be one of them. Excuse me. And now here's the Straight Wall, which is a huge cliff. It's 90 miles long, and it's 1,200 feet high. It was created when this part of the land dropped down, subsided from over here. And it's like a big crack. This is a crater called Burt A, and this is Burt, B-R-R-T. And this is how high. This is 1,200 feet. This is Devil's Tower out west, and this is what the height of that wall is. The slope is sharp, and if someone slipped off the edge of it and slipped down it, he'd have a heck of a time climbing back up. Here's another view of Apollo, of the straight wall. It looks kind of crooked here, but you can see where the land subsided here, and then it subsided over there. And somewhere in here, the Japanese orbiter, Cuyahoga, I think, I'm not sure of the pronunciation, they found a lunar skylight. There's lava tubes in various places on the moon, and the skylight is where the ceiling collapses in the cave. And scientists think that these lava tubes would make a good place to have lunar bases because it offers protection from the solar radiation, from the space radiation and radiation from the sun. Now we go to the south polar region. This is the crater Moretus and short. Moretus is 70 miles across. It's a complex crater. There's the central peak. Here are the terracing, and this has got one of the biggest landslides on the moon. This is a huge landslide, excuse me, that you can see with your telescope. Here's a lunar South Pole map. Here's where Moretus is, and there's short. And here is the crater Newton, which is the deepest crater known on the moon. I think it's about 5 miles deep, or 15 to 20,000 feet deep. And the crater Cabeus over here is where they sent that probe to crash into the crater to see whether or not there is water ice down below. And it turns out that there is. Here's the highest mountains on the moon are at the South Pole. They're much higher than the Himalayas. And again, they were all created by impacts. Here's Newton, here's Moretus. And here's where I think that water ice exists at the South Pole in these craters. And this is why it's being considered as a possible moon base, because the ice can be, the water can be turned into water, and the water can be broken onto hydrogen and oxygen.
Please leave a message after the tone.
Uh-oh, that was my answering machine. Sorry about that. Salesman. But anyway, these are areas where there are signs of water ice at the bottom of the craters. So Shackleton crater is one of them. Now this is a crater that is being considered for a moon base because it's almost in perpetual sunlight, 24/7. Not quite all the time, but most of the time. And they would have solar power up here. So they could put a base or something on the rim of the crater and have lots of electrical energy. This crater is 12 miles across. And I've seen a enhanced image of it. It's a simple bowl-shaped crater, like we saw at the beginning of the presentation. There's no central peak and there's no terracing. So it's a bowl-shaped crater, like Meteor Crater in Arizona. Now we've talked about bases on the moon. So why build a base on the moon? Well, these guys here can tell you. Hi ho, it's off to work we go. It's because there's valuable things. There's helium-3, which is known as tritium, and lots of titanium on the moon. So if you can mine this and somehow get it back to Earth, now Earth has more titanium, but this stuff, the helium-3, we don't have any commercially useful deposits of it. Just it can be made in nuclear reactors, but scientists think that this may be the key to nuclear fusion. So they'd be mining the moon, but not like this. And the titanium deposits, as I mentioned, are estimated to be 10 times greater than on Earth. And helium-3 extremely rare on Earth. It's valued at $40,000 per ounce, which is a lot more than gold. And I mentioned there's no large-scale commercial quantities available on Earth. And the lunar regolith, the soil at the surface of the moon, is not called dirt, it's called regolith, is estimated to contain about 13 to 30 parts per billion. There's not a lot of it in the regolith, but it's seen, this stuff is seen as the key to generating nuclear power through fusion. And the regolith, by the way, I forgot to mention this, when the Apollo astronauts were on the moon, they would go out and their suits, their spacesuits would be covered with this regolith, like a dust. And when they got back into their landers, got the suits off, they discovered that the moon has a smell, an odor, and it smells like gunpowder. That's what the regolith smells like. Regolith is finely pulverized rocks, and it's like sandpaper grits, and it's dangerous. You don't want to get this in your electronic instruments or mechanisms of any kind. And the estimate is that the regolith on the surface of the moon varies from 2 feet deep to 66 feet deep. And if you remember, there was a science fiction book about a resort on the moon where they had a machine that would take people across the surface. And back then they thought that the moon was covered with dust. And the ship called Selene got trapped in the dust, sunk down in it. And so the book was about the efforts to save the people on board the vehicle. But the moon's surface is not like that. The regolith is kind of like wet beach sand. You don't sink down into it. And fusion, when you take deuterium and tritium and use heat and pressure to fuse them together, you get the reaction, you get energy. And this is what scientists think nuclear fusion can be used to create energy that is basically almost pollution-free, and not like today's the current nuclear power plants where you have lots of radioactive pollution left over. So it's estimated that it would take $15 billion to set up a mining operation on the moon, but this is an artist's idea of what it might look like. And industrial scale mining of titanium and tritium. Russia and China are currently very much interested in this. They see it as a source of political and economic power. If they can get the tritium, especially, they can create a lot of energy without pollution. So Russia and China are actively working on being able to mine the moon at some point in the future. And hopefully the US is considering that too, and that we don't get left behind. Now, I mentioned that the tritium is like 13 to 30 some parts per billion, and you have to process 150 tons of lunar regolith to get 1 gram. And if you wanted to get an ounce, you'd have to process over 4,000 tons of it. And it's possible that it could be designed to use automated mining equipment that would kind of scoop this regolith up, process it, pick out the little parts of tritium, and then get it to some place where it could be sent back to Earth in a rocket. And this is what it would be used for: clean fusion power, tritium fuel. And of course, this is a very simplified version. Would produce hot water, run a turbo generator, and generate electricity. Might be in our future, or maybe not. It might be 30 or 40 years before we see anything like this. And here is Harrison Schmitt, one of the last men on the moon. This is a panorama, and I think this is probably, I don't know if it was full daylight. Well, maybe it was. It would have been very hot on the surface, 230 degrees Fahrenheit And so there's the spacesuits back then, and this was a long time ago. I'm sure spacesuits have improved since then, but would have to insulate against that and provide the oxygen. Here's the lunar buggy that they had, their radio connection, and somewhere out here, probably the device they use to navigate with. And here's a fun thing. How much would you weigh on the moon? You can pick your weight out here on Earth and go over here to see what you would weigh on the moon. When I showed this as a graphic thing at one of our star parties, a little boy was there and he figured out how much he would weigh. And then he says, "Mom, how much would you weigh on the moon?" And she said, "Never mind." You know, she didn't want to let him know how much she weighed on Earth. So if you're interested, a very good book, The Modern Moon by Charles Wood, and Discover the Moon by Lacroix and Legrand, two French authors who, this book takes you through night by night as the Terminator moves on the moon, going toward the sunrise and then back the other way, sunset. And you can see illustrations of what the sights to see, and it's been a very useful book. I've used it a lot. And that brings us to the end of our presentation.
Thanks, Bill.
Thank you very much.
Thanks, Bill. That was great. You know, you've got an object here that with even small telescopes, even binoculars, a person can explore the surface and see many of the things that you talked about tonight. So thanks. Let's throw the program out for questions. Anybody wish to jump in?
Any questions? I'll try to answer them. This, by the way, the image you're seeing is Monument Valley. And this is Orion.
Yeah, Bill, okay. The reason why the moon is the coldest place, I gather, is that certain craters, the bottoms they're near the poles, they never get any sunlight at all, and it's 480 degrees below zero or whatever you said.
Yeah, 400, yes.
Yeah, but if there are farther out moons, like moons of Neptune or someplace, and they, wouldn't they have polar craters perhaps, and would be even colder than the moon, or at least as cold?
Possible, I would imagine. The moon is almost, in those craters, it's almost as cold as space. And I guess space at 455 degrees below zero is the coldest you can get.
Absolute zero is about 459 degrees.
Mhm.
So it would be very difficult even in the far reaches of, you know, any of the other planets, moons, to get much colder, if at all, than the crater you're talking about.
Yeah, now Pluto is, I believe, 380 degrees below zero. So these craters on the moon are colder than Pluto. So they're currently the coldest known spots in the solar system. Any other questions?
Bill, I have a question.
Hi, Paul.
Hi, Bill. So I'm pretty new to all this, and what do you recommend for observing the moon in terms of filters? I see there are fixed transmission filters and variable polarizing filters.
Yeah, you could try a variable polarizing filter or a neutral density filter to cut down on the glare. Some people have stacked neutral density filters. Since my eyes are older, I'm not bothered by the glare. But out at Letha House, when I've had my scope on the moon, I've had people say, "Wow," you know, it just about knocks your eye out. And I'm over there like, "What do you mean? It doesn't bother me." But it's just imagine, it's just the age of your eyes. But yeah, neutral density or a polarizing filter would be helpful.
Bill, this is John. Why aren't the seas, the Maria, considered impact basins are the largest craters on the moon. After all, isn't that how they were formed? And some of them are, 500, 800 miles across.
Yeah, but they're not considered craters. They're basins.
Right.
Yeah, like Mare Orientale. And all of the lunar seas are basins of some kind. The only one they're not sure about is Oceanus Procellarum on the western side of the moon, the northwestern area of the moon, where Aristarchus is. Not quite sure how that formed, but it's all lava, and it's smooth and relatively smooth and flat.
Yeah.
Because the lava was, like I mentioned, was runny, like maple syrup, and it came out and over a period of time filled in the craters, all the little nooks and crannies on the surface of the moon. But anyway.
I mean, in essence, aren't they craters? I mean, most of them are circular. Most of them have for the most part, a raised rim around them.
Some of them are circular, like Mare Imbrium, the Sea of Rains. You can see the rim, but they're not considered craters. They're considered basins. Beyond a certain size, it's considered a basin and not a crater. Petavius, that I showed you earlier, might be approaching that limit where you get beyond, it's 106 miles across. You get bigger than that. At some point, the nomenclature changes and the craters become basins. But they are big and they're deep, but have been filled in with lava.
Bill, on the far side of the moon, looks like there's a lot more craters and it's a lot more rugged, but it doesn't look like there's any seas.
Yeah, there is one area of a sea, but the far side of the moon is the crust is thicker than on the near side, so they didn't break through to release the lava. But there is one section up near the northwest where there is a circular area. It's named after Moscovice. It's named after a Russian site. But the craters on the far side of the moon, there's more of them apparent because the lava didn't come out on that side. And the surface of the moon is considered thinner on the side that we can see. So, and the crust of the moon is shattered to a depth of about 25 miles, where it was cracked up by the force of the impacts that hit the moon. So the moon is, but over on the far side, on the back side, the moon's crust was thicker.
Bill, I've read someplace that the difference in crust thickness has something to do with the tidal effect of the Earth on the moon.
That's possible. Yeah, I've read that too. That it's one of the theories. But it, when the moon became gravitationally locked, and I don't know the mechanics of it, how it would, the moon was molten at one point, and it may have been completely molten, and so then those factors would come into, come into effect.